Welcome all. Welcome to this lecture of Object-Oriented Programming 1. Today we'll start with Unit 7, JavaFX Basics and Event-Driven Programming and Animations. Let me show the disclaimer, then I'll start the session. Okay, so uh, we have already seen some part of this Unit 7, right? We saw that first came AWT, then came Swing Components, and now there is JavaFX, right? And we saw what kind of framework is this, what support does it provide. We saw the basic structure of JavaFX. We also saw what is the application class, main class that we need to override, and we need to override its start method. Then we saw what is a scene object. Any node can be added to scene object, and scene object can in turn be added to stage object. Okay, scene object in turn can be added to the stage object, which is automatically created by JVM when the application is launched. So we have already seen that first comes the stage, which acts as a frame. Then comes the scene, which acts as a container, and there are nodes which are put inside a parent, which is nothing but a child of a scene. Okay, so this can be a pane or it can be a control or something else. Okay, so we have seen this, and then we saw what are panes, UI controls, and shapes. We show what are nodes. Nodes can be a shape or an image view or an UI control or a pane. Then we saw what can be a shape. These are all shapes that we can create. We'll see how to create them. And there are UI controls like these, which we can use to make forms. Okay, or rich user interface. Then we saw stack pane, and then we saw how we can add a button to it, how a circle can be added with a particular outline and also a field color, how a pane can be used and a circle can be added to the pane, and then that pane can be added to the scene, and then scene can be added to the primary stage, right? It was something like this, that you have a circle object which gets added into the pane object. Pane object gets added into the scene object, and the scene object gets added into the stage object, right? We saw this thing. We saw how this hierarchy is created. Okay. Now, we have to see the property binding. Okay. So we can bind our target object to source object. Okay. And okay, so this also we had seen what is a binding, what is a bindable object or an observable object, and what is a binding object. So we saw this example where, now see, property binding means what? That there will be a source object and there will be a target object. Okay, so here the source object is this, the pane, and the circle is the target object. This is the source object, and this is the target object. So if you change the width property, right, How do you change? You say you access that width property and then you divide it by 2. So you are changing the width property, which you are binding with center x property. You are binding with the center x property. So what happens is this center x also gets divided by 2. When you have height property of the pane, you divide it by 2. You bind it with y property. What happens whenever you change the height of this pane, the y property also changes. If it's like a pane and you are, let's say you are resizing that pane, right, like this, then what would happen is if a circle is at the center, then its center would also change. If you make this small, then obviously the circle would get shifted over here, right? So that's what is an example of property binding. Okay. Now there are common properties and methods for nodes. An abstract node class, the abstract node class defines many properties and methods that are common to all the nodes. Like we have seen style. We saw how we can see set the style, the stroke, that is the outline, the fill, that is the inside color, right? This is for circle. So this style acts as a CSS, JavaFX CSS. Then we also saw how rotate works. We can rotate anything, even a button. Okay. And since it's a positive degree, it starts rotating in clockwise direction. Then we saw color class, right? This is a color class, which is a concrete subclass of paint, which is used to encapsulate colors, and it can be used to create colors. We saw how this color can be created and how various operations can be done on it, right? So let's see one example of this. Okay, what I've done is, guys, see, check this out. In all all JavaFX programs, I've kept all the programs, and there are lab programs also and lecture programs also, and all this things, all this other examples come under lecture programs. So if you see the color font image, the color font example, so check this out. Here this color font example does what? Here we have this demo effects color font extends application. Okay, so we override its start method, which gets a primary stage from the JVM when the application gets loaded. We create a stake pen object. We create a circle, set its radius to 50, set the outline, that is the stroke, to black, set the fill colors by saying new color, and we specify RGB values and opacity. One means for 100%, and then we set pane.getChildren.add circle. So we add this circle to the children of the pane. Okay. Once the circle is added, now what do we do is we create a new label, JavaFX. Okay. And we say label.setFont. We set the font by using font class. How do we specify the font? By saying font.font. Font class font method, which is static method. We use the static method. We provide the name of the font weight, font posture, and the size. Okay, and then we add the label to the children of the pane. And now what do we do is we say new scene pane 200, 200. So that pane is created for size 200 by 200. Okay, and then we set the font demo as the title of the stage, set the scene main as the main scene of the primary stage, and then show it. So let's run this out. What happens? Let's see. sorry, not debug, we have to run it. Check this out. Since it's a stack pane, everything gets stacked onto each other. Okay, everything gets stacked onto each other. So you can see the circle is there and the word JavaFX got stacked onto it. So you can see how font can be manipulated. Okay, and how circle can have different colors. Harshit is asking, is it necessary to import all the classes like scene, stage, button, etc.? Yes, Harshit, we need to, because each and every class belongs to a different package, right? See, our demo FX color font is put inside this package, and all these classes belong to JavaFX package. So we need to import them. Whichever we are using, we need to import them. As simple as that. Extending the application class just makes our class as a JavaFX application. It does not give you all the classes. You need to import them, make use of them, add them to your scene. Okay, add them to some container which can be added to the scene, and then that scene gets added to the stage. Okay, that's how it happens. So color class can have even these kind of colors, ready-made colors. You can see all are in capital, means these are constants. These are constant values that can be provided, okay, to create the color or to set the color of a particular object. Then we saw the font class today. Font class describes font name, weight, and size. Okay, and we can set the fonts for rendering the text. So it is javafx.scene.text.font. So it comes under text package. javafx.scene.text package. And font is defined what? What do we set? We set its name, the weight, the posture, and the size. Okay. So name is this Times New Roman or Courier or Arial, right? And weight can be numeric. Okay. And then we have the posture, which is nothing but either it can be italic or it can be regular. Okay, either it can be italic or it can be regular. Now, and you can even get the font family names by invoking get families method. Okay, if you don't know the names. So see, this is the example. Here we say we create a font instance by its constructors or its static method. So we say new font, the font name, and the size. Or we say font.font. So this is static method where we define the name, the weight, the posture, and the size. Okay. So we just saw the example where we created a label, set the font for that particular label, and added that label to the pane, right? Now these are some of the methods of font class. Like these are the constructors. These two are constructors where you provide the size or the name and the size. And then once you have set the created font, right, you can okay, so these are also constructors, but there is a typing mistake over here. So you can provide name and size, you can provide name, font weight and size, you can provide name, font weight, posture and size. Okay, and there is get families, which gives the list of all the font names, font family names, or you say get font names, which gives the list of font names, and there are getter methods. Then comes the image and image view classes. Okay. Image class represents a graphical image, and the image view class can be used to display an image. Okay. So Java fx.scene.image class represents a graphical image, right? And is used for loading an image from a specified file name or even URL. You can use URL also or a file name also. So the image view is a node for displaying an image. Okay, and image view can be created from an image object. So first you create an image object. First you create an image object, and you use it to construct the image view class or object. So image view consists of an image, and this is the main node which will be used, which will be inserted inside a pane. You see, you have a new image where you specify a URL or a path. Okay, and then you say new image view image. You can even specify a file stream to read the file. Okay, and then you can convert it into a image. So, or you can even directly use this path to create the image view, right? It might be possible that you might have separate image objects in your application, and then there might be an image view where you might need to add those objects turn by turn, right? So that's why this particular technique is preferred, where you basically first create the image and then you create the image view out of it. Here you provide the image. Okay, this image is provided over here. So let's see an example of fx image. So check this out. Here uh, we are using image. Okay, so what do we do? Check this out. This demo fx image class extends application. So we override the start method where we get the primary stage. Now we first create a pane, and this is an horizontal box. Different types of panes, where this is horizontal box, and horizontal box of size 10. And we set its padding. We say new insets 5555. We put the padding of 5 on all the 4 sides inside this pane. So whatever objects gets inserted, the insets get applied onto it. Then we create a new image by saying new image, new file input stream. This is the file input stream. You use the file input stream to read this file and convert it into an image. And then you say main.getChildren.add new image view and add that image to the image view and then add it. So image view can be added to a container. Remember that an image view can have image inside it. Okay. Then what we do is same image is added into a different image view 2. Okay, and then we set its height and width. We say set width height 100, set width height 100, and then we get the children of the pane and we add the image view to it. Okay, here also we can also create one more. We can, but let's see what happens. Let's first add only one image. Okay, then we see what happens. So once we have created the image view and added it to pane, we add the pane to the scene. We set the title of the stage, set the scene for the stage, and we say stage.show. So let's run this out. See, this application.launch is required only if you are running this through this IDE or something. But if you are running it through command line, then you don't require it. Okay, that's a different way in which you can invoke it. We already specified in our slides. So let's run this file. Here it is. This is the image. Check this out. Since this image consists of an horizontal box, H box, what happens is if you add one more image to it, it gets added horizontally to it. Okay. So now see, we are restricting its size. Okay. So we run the file and you can see that this is 100 by 100. So this was the size, original size, which got converted into this much size. See that? And now if we add one more, what do we do? Check this out. We use the same image object to be added to the new image view, and then we say set rotate that image view to 90 degrees, and then add that particular image view to the pane. So see what happens is we run the file, it gets added like this. You see that the same image got rotated over here. Okay, by 90 degrees. So this is how the image works. Okay. Now there are layout panes. Okay. Now there are many types of panes for automatically laying out the nodes in a desired location and size. Okay. For example, if you want a simple layout, like you want to all the elements to be put in sequence like this. Okay, in like this sequence. Then you may want a simple H box. You may want a simple H box, horizontal box. Suppose if you have all the elements to be added like this, then you use a simple V box. You want to stack the elements onto each other like this, you use stack pane. You want the elements to directly flow, it can be in this manner, and if the window is minimized, it may even come to this. So in this manner you simply use flow pane. If you want a specific grid to be used, right, for specifically allocating or locating the elements, a specific grid needs to be used, right? Then you use grid pane. You want specific borders, then you use border pane. So pane is what is the base class for layout panes. It contains getChildren method for returning a list of nodes in the pane. Okay. And there is this, now comes the stack pane class, which places the node on top of each other in the center of the pane. Then there is a flow pane, which places the nodes row by row horizontally or column by column vertically. Okay, you can define whatever flow you want. Then there is a grid pane, which places the nodes in a cell in a two-dimensional grid. Then we have border pane, which can place the node in top, right, bottom, left, and center region. So we have 5 regions inside border pane where we can place the objects. Then we have H box, which places in a single row, and V box, which places in a single column. Okay. So let's see the layout panes examples. If you see the layout pane examples, the layout pane examples are given inside this FX pane package. Okay. So let me show you one by one. Let's see the flow pane. We have already seen stack pane, right? So let's see some other panes now. Check this out. This is this is demo FX flow pane application. We have a start method inside which we add a new flow pane. We can create a new flow pane. We set the insets inside it to be 10 on all the four sides, and set this insets as padding. We also set H gap and V gap, horizontal and vertical gaps inside the pane. And then we set the orientation of the flow to be orientation dot vertical. So whatever we add gets added into a single column. And we say that alignment, we set the alignment to be position dot top right, pos dot top right. Okay, so you can see most of the classes are available easily, and uh, many constants are available in order to set the properties of some particular objects. So here we are setting the properties of the pane object. Now once the pane is set, we add lots of objects to it by saying pane.getChildren add all. We were using till now only add method, but now will be using add all method. Okay, we create a new label, new text field. Okay, then new label, another text field, then new label and another text field. Okay, so we create 3 labels and 3 text fields, and then these are already added to pane, right? So we say new scene pane 700 comma 200, and then we set the title, then we set the scene as the main scene of the stage, and then show the stage. So let's see what happens when we run this file. There will be 3 text boxes and 3. Check this out. This is the width, which is 700, and this is the height, which is about 200, right? And you can see we added 3 3 labels and 3 text fields. You can see all are sequenced one after another. So this is a flow pane. Okay, this is an example of a flow pane. Even if you resize it, you can see it remains on the right hand side only. Why? Because we have set the orientation, sorry, the alignment of all of this pane to be top right. You can even change it. You can say pos dot. See, there are lots of there. We can put it into center. Okay. Now if we run this file, the form would look somewhat better. You resize it, it stays into the center only. Okay. Then you have grid pane. In this grid pane, in the start method, we say grid pane equal to new grid pane. Then we set the insets for it. We set these as the padding, set the horizontal and vertical gap, and then we set the alignment as center. And here also we set the label. Now see, what we do is we say put this label at 0, 0, put this text field at 1, 0. Again we say a new label is there which has to be put on 0, 1. New text field is there which has to be put on 1, 1. Then there is a new label that is to be put on 0, 2, and new text field is there which is to be put on 1, 2, right? So what is all this? You first have the node child. This is the node child, and these two are basically the column index and row index. Okay, once we have added this 6 elements, then we add a button. We say add name, this the button, and then we add the button at 1, 3, that is below this text field. And then we say grid pane dot set H alignment. We add the button and we set it to the right position, horizontal position as right. Then we set the scene by adding the pane to it. Set the title of the stage, add the scene to the stage, and show the stage. So let's run this out. Check this out. So here we have what? Here we have a grid pane where we have added three labels in this particular 0. So this is 0 comma 1, 0 comma 2, 0 comma 3. This is 1 comma 1, 1 comma 2, 1 comma 3. And then we add this. Horizontal alignment is on the right hand side. You can add something, but now it will not work because we have to add the code. You have to specifically add the code for adding this name to somewhere. You can even say this is here, it is left, alignment is left. And now if we run this, it comes on the left hand side. You see that? So that is grid pane. Now if we see Hbox and Vbox examples, and then we'll see border pane example. Hbox, Vbox, check this out. Here what do? We have a border pane. We set the Hbox. We get an Hbox and set it as the top of that pane. Get the Vbox, set it as the bottom of the pane. Set the pane to the scene. Okay. Now this get Hbox does what? Check this out. It creates an Hbox of element size 5. Now sets the padding. Creates new rectangle array with 3 rectangles. Okay. And then sets its style and adds those rectangles to the Hbox and then returns the Hbox. Similarly in Vbox, we create a new box of 5 elements, set its padding, create 3 circles. We create 3 circles over here. We set its style and add the circles to the Vbox and return the Vbox. So those Hbox and Vbox get added to this pane. Hbox get added to top, Vbox get added to bottom. And then we create the scene and set the scene as the main primary stage. So let me run this and show you what happens. Check this out. So the upper part is Hbox, the lower part is Vbox. You can see how the node objects are aligned. Since it's an Hbox, all the elements are aligned over here in horizontal phase. Since this is an Vbox, all the elements are aligned in vertical phase. Okay. Now we have border pane. In border pane, what happens is we can set top, right, bottom, left, center. At these 5 locations we can set. So in each location we add a new custom pane: top, right, bottom, left, and center, named as these, right? And then we set the pane to the scene, set the title, set the scene, and show. So check this out. We run this file. You can see, since it's a border pane, it has got regions. These regions are there, and borders are also assigned to it. We can even change the borders, but right now you can see how these locations or these boxes are aligned. So top covers whole column, bottom top cover whole column, left and right are inside between this, and center comes over here. You see that how it is aligned? Yes. So now we can add various components to these. Now see, this custom pane is our own class which extends stack pane. where we pass some title to it in its constructor. We say get children dot add new label. This title is added as a label, and we also set its style. We say fx dash border dash color red. You can even set it to black. And then we set the new insets as 30 on all the sides and set it as the padding. So check this out. We run the file, and there it is. You see that? See, because of the paddings, you get to see these much size. And in fact, this is the width. So that's why the panes have automatically adjusted to that width. Suppose we create 50 padding. So this is how it affects. You see that? Since padding is given, these all have some space on all the four sides. Okay. What if we don't give the padding? And we run this. You can see how much small it is. Yes. Now you have to see, once we maximize it, these panes did not show in space, and it wraps it very tightly. It wraps the text very, very tightly. Only the center part automatically gets expanded, and none of the four sides gets expanded. Top, right, left, or bottom does not get expanded, because we have not specified any padding. So now if we specify the paddings, then it looks proper. And you see, as much as we maximize, the left and right's width remains as it is, and the top and borders height remains as it is. You can see that the left and right's width does not change much, and the top and borders height does not change. Okay, so these are some of the properties that you have to remember. Okay, now let's go back to shapes. So JavaFX also provides many shapes classes like text, lines. Text also come under shape. Lines, circles, rectangles, eclipse, arcs, polygons, polylines. Shape class is an abstract base class that defines common properties. It has properties like field, stroke, stroke width. Okay. Now we'll look at all these classes. Okay. These all are subclasses of shape. So first let's take text class. Text class basically defines a node. Node can be added to a container, right? Like pane. So the text class defines a node that displays a string at a starting point of x and y, at a location xy. The text object is usually placed inside a pane. The text object is usually placed inside a pane. And the pane's upper left corner is 0, 0. So this particular corner is 0, 0. This is the main. Okay. So a string may be displayed in multiple lines separated by new line. So these are some of the properties of text class. The text itself, the string property, defines the text to be displayed. X, that is the double property. So these are the names by which these are known. Okay, these are the types. Text is a string, X is double value, Y is double value. Defines the X and Y coordinates of the text. Underline, which is a Boolean property, can be true or false. So default is false. Defines if each line has an underline. Strike through, Boolean property, defines if each line has a strike through. And also a font property, where the object font property is there, which defines the font for the text. Then we have text constructor, which creates an empty text. A text constructor with a string, which creates a text with a specified string. And a text constructor with XY values and the text itself. So this creates a text with a specified X and Y coordinates. And even getter setter methods are there. Then there is line class, which has got properties and methods like start X, start Y. So from which X and Y the start line starts, and from which X and Y line ends, that is end X and Y. So this is one pair, this is another pair. Okay. You have an empty line object, line object constructor with start X, start Y, end X, end Y. Then you have a rectangle class, which also is defined by parameters like XY, width and height, arc width and arc height. Rectangle's upper left corner is at XY. Then you specify the width and height. Parameter AW arc width is the horizontal diameter of the arcs at the corner, and parameter AH, that is arc height, is the vertical diameter of the arcs at the corner. So you have X, which is double property, Y, which is double property. This represents upper left corner, X and Y. Then you have width and height. This is the actual width and height of the rectangle. And then you have arc width and arc height. Okay, which is basically the arc width of the rectangle, which specifies from up. Suppose if this is the, let's suppose that this is the X and Y location that you specified. So now whatever you specify as arc width and arc height, accordingly the rectangle gets created. Okay. So arc width represents that from this point, how much the rectangle width is there, and from this particular point, what is the rectangle height that is specified. Then we have a rectangle constructor, with XY and with height. So XY represents what? The upper left corner, right? And width and height specifies how much the rectangle expands. Then we have circle class, which can have center X and center Y, and radius, which has got, it can create empty circle, a circle with XY value, and a circle with XY and radius. So see, Center X and center Y represents this particular location. Okay, this particular location is represented as center X and center Y. And this is ellipse class, right? In this, what happens is there is a radius of X and there is a radius of Y. So X and Y radius are different. In circle, there is only one radius. Here we have two radiuses. Okay, so this is one radius. This is radius X, Y, and this is radius X. Radius X and radius Y are different. Okay. So Eclipse class methods are basically like this. These are the Eclipse constructor, no argument constructor, constructor with X and Y, center, and Eclipse constructor with X, Y as center, the radius for X and radius for Y. Then comes the arc class. Now, what is arc class? Arc basically, see, arc represents a part of a circle or an eclipse. Okay. Here, arc is considered as a part of eclipse, not circle though. Circle can be termed as a subtype of eclipse. So arc class is defined by the center X and center Y. That is this location first. This location is specified first. That is the center X and center Y. Then comes radius X and radius Y. Radius Y, that is this radius, and radius X, this radius. Okay. And then the starting angle is defined. So see, this is the starting angle. This is the starting angle. This represents the starting angle, start angle. This is 0 degree over here, and it goes into this direction. Okay. So we have center X, center Y, radius X, radius Y, start angle, and then the length and arc type. So the length is this part. This part is the length. It is specified with the help of length. How much the arc needs to be taken ahead. Okay. So the parameter start angle is the starting angle, and the length is the spanning angle. This length is what? It's the spanning angle. So this angle, this is basically length. This angle is the length angle. And the angles are measured in degrees. Okay. Which are the properties of our arc class? Center X, center Y, radius X, radius Y, start angle, length, and type. This specifies whether the arc is open, it's a chord type, or it's a round type. Okay. We have this arc constructor and arc with all these parameters: X, Y, radius X, radius Y, start angle, and the length. And then comes the polygon class. After that, we also have polyline. So let's see the last class, that is polygon class. Polygon class defines a polygon that connects a sequence of points. The sequence of points are important. So polygon class is similar to polyline class is also there, which is similar to polygon class, except polyline class is not automatically closed, whereas this polygon is automatically closed. So you see, you specify points like this, and this line automatically gets created. In polyline case, this line over here, this line does not get created. It's the only difference. What do you have inside polygon? Either an empty polygon, no argument constructor, or you provide points. You give the array of points, and you can have get points method, which will give you a list of all the points, xy coordinates. So that's it for today. In the next section, we will see all these examples practically. Okay. If at all any doubt, please do let me know. We will also see these classes with the help of programs, and I have uploaded these programs onto my repository also. Okay.